Hey guys, welcome back. Today we're going to continue with section 9.1 from the book with our right triangle trig, so let's just jump right in and get started. So here we have a problem where we're trying to solve for x right here. This would be really easy to do if we knew the value on this side, because then we could just do the Pythagorean theorem. But since we don't have two known sides, but we do have a side and an angle, we can do SOHCAHTOA and really easily solve for it. So again, I always like to write SOHCAHTOA up at the top of my page just because it kind of helps me visually see what trig function I should be using. So from this angle here, the side that's labeled x would be the adjacent leg, and 9 is the hypotenuse. Over here is the opposite side, but there's no number over there, so it almost doesn't matter that we label that one. Okay, so now I have to pick out what trig function uses adjacent and hypotenuse, a and h. And when I look up here at these letters, cosine is the one that uses a and h. So I'm going to set up my problem like cosine of 30 equals, and I'm doing in this order, adjacent over hypotenuse. So that would be x over 8. Okay? And from here, since we're trying to solve for x, but right now it's being divided by 8, if we just multiply both sides by 8, that will go away and we'll be able to get x by itself. So now what that says is 8 times cosine 30 equals x. And now all I have to do is type that part in on my calculator and we'll get the answer. Make sure again that your calculator is set to degrees from the last video. Once it's set to degrees, it won't ever switch back unless you change it or unless you reset your calculator. So if you ever had to reset your calculator, that'd be a good thing to go back and check. And typing that in, I'm getting 6.93 equals x. So now I've just solved for x and we're good to go. Alright, so in this next example, it just gives us generic directions that say solve triangle ABC. And what that means is you need to find all the missing sides and all the missing angles. So there should be nothing unknown in this question if the directions say to solve triangle ABC. That means do everything. Okay, it's not as overwhelming as it seems, because once you do one, the rest kind of fall into place pretty easily. And so let's just go ahead and start. We have lots of missing sides. Not lots, but we do have two missing sides, A and C. Luckily, we already know B. Since I only have one known side, though, I can't do the Pythagorean theorem, so again, I'm going to have to use SOHCAHTOA to figure out either side A or side C. It doesn't matter which one we want to start with. I'll go ahead and do side A just for the heck of it, but we definitely could have easily solved for side C first. It doesn't really matter. Okay, so from the angle that's given, side A is the opposite side, and the other side that we know, which is side B, that's 15, that's the adjacent side. So now I have to say, okay, what trig function uses opposite and adjacent, O and A, and that would be tangent. So then I can write tangent of 28 equals A over 15. And from here, I'm trying to solve for side A. It's currently being divided by 15, so I can times by 15 to get rid of that, as long as I do that to both sides. So now all I have is A is equal to 15 times tangent 28, and that's just a simple thing that you can type in on your calculator. When you type it in on your calculator, you get 7.98. So if you need to look at this work, pause your screen and write some of this work down. I'm going to erase everything I have written in green and just fill in 7.98 into my triangle. So pause now if you need it. So at this point, we do have two known sides. I have A, I have B. I could just do the Pythagorean theorem, A plus B squared equals C squared, and plug these numbers in for A and for B, and then I could find C. But honestly, after doing SOHCAHTOA, I think that goes a lot faster, and I'm just going to continue doing SOHCAHTOA. But if you would prefer, you definitely could just do the Pythagorean theorem. Okay, so I'm going to do SOHCAHTOA using the same side that we were already starting with, B, and then solving for C. So from my angle that's given, from this angle, B is the adjacent side, and C is, of course, the hypotenuse. So that's A and H, which means we're going to use cosine. So I can say cosine of 28 equals 15 over C, and now I have to solve this for C. The only thing is, in this one, since c is not in the numerator, so other examples that we did earlier looked kind of like this, and all we would have to do is like times by 8 or something like that, and we would have x by itself. In this example, notice that c, the variable, is the one in the denominator. So we're going to have to do things a little bit different. And since that's the one in the denominator, I'm going to have to multiply by c to get that out of the denominator. The only thing is that's not my final step. So now I have c times cosine 28 equals 15. And now from here, what I do is just divide by cosine 28. And now I have c by itself. So it wasn't hard math. It was just 2 steps instead of 1 step. And now I have c by itself by typing on my calculator 15 divided by cosine 28. And when you type that in, you will get that that is equal to 15.99 if we're rounding to 2 decimal places. Alright, so pause your screen if you need to look at this. I'm going to take that 15.99 and write it over here in my picture. And now the last step is we just have to find this one missing angle over here. The really, really awesome thing is we already know 2 of the other angles. We already know this is 90 and this is 28. And remember, there's only 180 degrees in a triangle. So to find the remaining piece, I could just do 180 minus 90 for right here, minus 28 for right here, and that will tell me what is left over. When I type that in my calculator, I get 62. So that means that angle B is 62 degrees, and I'm done. So the angle part was not bad because we already know 2 of them. Okay, and that's what it means to solve a triangle. I have now found all the sides of the triangle, none of them are unknown, and I know all 3 of the angles of this triangle. So there's nothing left unknown in this problem. Alright, so I'm going to have you guys try a couple on your own. Part A is just solving for x using SOHCAHTOA, and part B, you're solving the entire triangle. So draw a picture using this to information. If you do need a quick refresh, remember capital letters are the angles, and lowercase letters are the sides. So let me actually draw that picture for you. If we have a right triangle, and it doesn't say this is a right triangle, but this is inside of the section where we're studying right triangles, so we can assume that. Normally that would probably be given to you though. And we're going to call it capital A, capital B, capital C. Those are the angles. So the part that says 32 degrees I'll put for angle A. And the part that says lowercase b, that's a side length, not an angle. And the side lengths are always opposite from the angle. So since angle B is over here, the side across from that is here, and that's the side that's going to be 10. So now that you have that set up, you can solve for all the other sides, the other 2, and the other missing angle, which is angle C. So pause the video here and work on part A and part B. Alright, so here are my answers to these questions. For part A, I got x is 4.24, and I got that using the cosine function, and then multiplying both sides by 6. For part B, I got that lowercase c, this side right here, this length is 8.48, and side A, this side right here, is 5.30. And then angle C, this angle is 58, and I got that just by doing 180 minus 90 minus 32 to get the remaining amount of angles. Now, I do want to say one thing. If you got either one of these wrong, you might be typing things in wrong to your calculator. For instance, like for finding lowercase a, this side right over here, since that's the opposite side of this angle, I use sine, and so I did sine of 32 equals opposite over hypotenuse, so a over 10, and then multiplied both sides by 10. If you are typing it in like sine, and then your calculator automatically does parentheses, make sure you're closing that parentheses before you multiply by 10. Some of you might accidentally be typing it in like this, and it's doing sine of that whole thing, which would be wrong. So just make sure that you're closing the parentheses like I did up here to make sure that you're getting those correct values. Once you have those, we're ready to move on to the next slide. So if you need a second to look over those answers, pause the screen now. Alright, so the next example is just a simple word problem. We could read everything that's written in this paragraph, but everything's already labeled for us in this picture, which is nice. The only thing we really need to look at is what the question is. How wide is the canyon between A and C? Capital A and capital C, which means those points. So I'm looking for the length of this side of the triangle. That's really the only important thing to make sure I read out of this, is knowing what is going to be the thing that I'm solving for. So I need to solve for x. So luckily, since this is a right triangle, and I have an angle and I have a side, I can just use SOHCAHTOA. So what trig function are we going to pick? From this angle right here, 76 degrees, this side would be the adjacent leg, and side x would be the opposite leg. This side right here is our hypotenuse, and I can tell that because it's right across from the 90-degree angle. So I need to focus on what trig function uses adjacent and opposite, A and O, which would be tangent. So I can say that tangent of my angle, which is 76, equals, and I always go in this order, opposite over adjacent. So that would be x over 2. And to solve for x, I'm just going to multiply both sides by 2 to get it alone. And so I have 2 times tangent 76 equals x. Typing that in on your calculator, you should get that x is about 8.02. And our units here is miles, so I'll just make sure that I include that. Okay, and that's it. So these word problems, they always seem like they're overwhelming because there's a lot of words, but the actual math involved is very, very simple. So this was just like, honestly, almost exactly like the very first example I did in this video, and it takes a lot less steps than the problems that ask you to solve for the entire triangle. The only thing that feels overwhelming is when we see a bunch of words. So don't feel overwhelmed. It's not going to be a more difficult problem. Alright, and the last example we're going to do today is just reminding you about angle of elevation and angle of depression. Angle of elevation is if you're standing here and you're looking like up at a building or like some sort of object that's going straight up and down, a tree, things like that. And you're looking up. So the angle of elevation is right here looking upwards. The angle of depression is if you're already at the top and you're looking down, and the angle of depression would be right here. Notice that these two lines, this one and this one, these are parallel lines. And so actually angle of elevation and angle of depression, this angle and this angle, are alternate interior angles, which means that they are equal. So your angle of depression and your angle of elevation will always be the exact same angle. Alright, and let's use that fact to do the last problem for today, which is just another word problem, just like the last one, except for the only difference is it describes an angle of elevation, and so we just have to know where to label that. So this one we're going to have to read. A parasailer is attached to a boat with a rope that is 72 feet long. Alright, so if you've ever been parasailing, you would know if you have like a boat here and you have some sort of string and you're here flying above the ocean, which would be like down here. So it's telling us that that string is 72 feet long. And it's saying the angle of elevation from the boat, so from here looking up at the parasailer, is 28 degrees. So if I draw a right triangle, this is 28 degrees, the angle of elevation looking upwards. Alright, and I can draw in my 90-degree angle here because measuring this height, this up and down height, would be, of course, a perpendicular line from the person in the air down to the water. It'd be a straight line. So I know that that's going to be a right triangle. And what I'm looking for is that height. I'm looking for the parasailer's height. So this is my x. I'm looking for how high up they are off the ground. So now that I have the triangle drawn, which is the hardest part, this is not going to be a hard math problem. The hardest part is just reading these two sentences and being able to draw this picture. But now that I have that, the math is going to be pretty easy. So I have an angle. The side across from it is the opposite side. And the other side that I know, the one that says 72, that's my hypotenuse. So now I just have to think what trig function involves O and H, and that would be sine. So I'm going to say sine of 28 equals, and I go in the order of O, H, so x over 72. And now I just have to solve this out for x. So doing that, I would just multiply both sides by 72, and I get x is equal to 72 times sine 28. I'm running out of room there, so I'm writing it small. And typing that in on my calculator, I get 33.80. So, and what's our units here? It looks like we're measuring things in feet. So I know that the height of the parasailer is 33.80 feet above the water. And that's it. So this is nothing more than just a SOHCAHTOA problem. We just had to first read the words and set up the picture, and that's what makes it a little bit more difficult. All right, so that's it for today, you guys. Good job. And again, hop on office hours if you need any help. I'll be happy to help you guys out. Have a good rest of your day.